Nano fam, welcome back. Another stream. And as you can hear, I chose a different playlist for today because of the complaint last time. I thought let's try different types of music. So today something chill. We are going to relax today, like chill coding session. So hello guys, hello Andefnal, hello Sergio, finally on time. Hi, Papai Chista and Ili Bob and Amadeus. Welcome. So let me just add you to the spinner wheel. And let's see what we can do today. Maybe we can maybe we can finally make some progress with our network code. Hi Dominic, Nano to the moon, yeah. All right, so I have on the spinner wheel, so let's just switch to the screen. I have on the spinner wheel you guys, so if anyone's missing, if you want to participate or in the Nano giveaway, just post your Nano address in chat. Okay, I hope I haven't forgotten anyone. Amadeus, yeah, I think Liz looks good. Dominic is from Brazil. Hey, Brazil. That's far away from where I am. All right, so guys, today's Tuesday. We had another dev meeting today, and if Null says, "Oh, this rigged wheel." Where is LF? Yeah, LF. He wrote me that he won't be able to join today, but maybe next Tuesday. Nanomug. So, what do you guys think of the chill music? Do you like it more or less? All right. So today we had another dev meeting on Twitter. And Piotr's exciting branch was merged after that, and that merge brought in a change that lets the Nano network recover from a heavily desynchronized state. So I think he tested it with like 2 million blocks desynchronized, and with his changes, the Nano network, it can just recover at a very high block rate. And that is so exciting because that was always a problem in the past when the nodes got desynchronized, that the network would stall. And with this branch now, like a heavily desynchronized network, that could happen in a spam attack, would be just resolved. It would be resolved with a very high throughput, and yeah, that's just exciting. And I haven't ported that code into RS Nano yet, but I'm going to do this this week or next week, and then we can maybe I can publish a new Docker image of RS Nano then, so that maybe you guys could test it or run it yourself. Yeah, and the flower says, wow, that's cool. Did this ever happen in production or on the testnet? Yeah, it did. There was this huge spam attack. When was it? 2 years ago? Last year? I'm not sure when that. So there were multiple spam attacks, and there was, yeah, a huge one, I think 2 years ago, and that brought the network to basically to a halt, and the attack vector that the attacker used back then was fixed, but still there was a problem when there was just a huge backlog or a huge desynchronized state. And yeah, with the new version coming up, that's looking really good. So I'm very excited about that merge. So yeah, so this is always like a race between spammers and us programmers. So we will never reach a state where we can say we don't have to do any work on spam mitigation. But I think we can come to a point where attackers, like they will have it really hard to attack the network, and that's the goal. to make it commercial grade. So Anna says, how is the weather in Germany, by the way? Oh, it got really cold suddenly. So on Sunday, really, really cold, like 0 degrees Celsius. How is it for you? Where are you from, by the way? Where are you from, Andefnal? And you others, like we have people from Brazil. Which countries are in chat? Slovakia. Oh, is it colder? How cold is it in Slovakia? And if not, it's not that cold, but finally it's getting colder. Yeah. Yeah, the summer was really hot here. From Canada, Amadeus. Hey, Montreal. People from all over the world. That's really cool. Okay, so so this is the spinner wheel, and oh, I have to start the block timer. Yeah, here we go. So in 10 minutes, when Bitcoin manages to create a block, we send out 1 nano to 1 random lucky winner. So hello guys. So hello to the new guys. So we are working on the RS Nano project. We are porting the Nano cryptocurrency node from C++ to Rust. And if you want to know more about this project, you can visit rsnano.com and you can find all of the information there. So last stream, I did not work on what we did on stream. So we are picking up from where we left last time. And I think we didn't do much last time. We tried to get rid of the Tokyo socket facade. This struct here was there because it made porting this async code to Rust simple, but now we don't need it anymore. And we want to integrate our testable TCP stream into the socket struct, and then maybe we can even delete the socket struct. And last time we inlined the code for reading some bytes from the network into the socket struct. And that was... let's find the place. It was... here? And then we stopped coding. I think we did a little bit of a cleanup, but then I couldn't concentrate and I stopped the stream. But now maybe we can find a way to progress here. Dominic says live on TikTok is better, bro. Can you stream on TikTok? I've never used TikTok. I think I'm too old for TikTok. And if now says, that's a slow network, this Bitcoin. Yeah, this Bitcoin is really, really slow. Imagine having to wait for 10 minutes for your transaction to go through. Unbelievable. Or maybe even more, like it's not guaranteed that you get it in 10 minutes. So we inlined the code and we called this function async read to, and we inlined all of that ugly code from the TCP socket facade. And yeah, so what I want to do is I want to make this an async function. And so that we can throw out all of those callbacks. And maybe what we could try is maybe we could duplicate this code and make it async, and then slowly, one by one, using the async version of it. And once all usages use our refactor to use the new function, then we can delete the old one. I think this is a good way to go. So usually I like to go in small steps, and also I like to refactor in very small and safe steps. So I don't have a problem duplicating code as long as it is just for a short amount of time, with the goal of deleting the duplication then. So, and also what I really don't like about this code is the handling of timeouts. This socket struct here, it has a field with the last completion time, and then there's a separate thread running, and it periodically checks this timestamp, and if that timestamp is too old, then it marks the socket as timed out. And I don't like that approach at all. So I would much rather have the timeout handling in the part that does the reading, that executes the read, because we even have different timeouts, I saw. Because if we look for usages of async read, async read, then we find here this read impl, and so this is basically the C++ code converted to Rust. And what it does is, whenever we read a new message, it increases the timeout here, so it gets the old timeout. Then it sets a new timeout to a higher value, to the idle timeout, which is, I think, 2 minutes by default. And then it does the read of the message header. And after that, or of the message, and then after that it resets the old timeout. And that's just I don't like it. It looks weird, and maybe it's error prone. So what I would like to have here is, I would like to have the timeout at the place that triggers the read, because then we can just easily have different timeouts, and maybe we can get rid of this cleanup thread, or this, how is this thread called, that checks, that periodically checks, ongoing checkup. So this is the function here that every 2 seconds runs this code. So every 2 seconds it checks if the socket is alive and closes it, or if the... Ooh, this is also like a mess. So it checks here, it checks the timeouts, if this timeouts, so if the last read, the last completion time is too high, it just drops the socket, am I right? Yeah, it just says socket.close, and this should cause the socket to be dropped. So I think a better design would be if we would handle the timeouts in the part that actually reads the code, reads from the network, and when when a timeout happens, it could just close the socket. So this would be much simpler, and this is where I want to go. DMA says, congrats for the work done. Thanks. So post your Nano address if you want to take part in the giveaway. Yeah, I worked on the active transactions class this week, and just by the way, so that you guys know what I have been doing, and that is the heart of the election code. And once we have that in Rust, that's also another small milestone, because yeah, it's just a lot of code, and it is complex code, and it does all of the logic involved with elections. And yeah, having that in Rust would be like really cool, and I hope I can, yeah, I hope I can get it done in a week or two. So okay. let's see where we can write our first bit of code. So let's go back to the async read function. So here we are, async read 2, and we want to make this async. And should we just copy it and make it async? Let's try. So let's duplicate this. And as I said, duplicating code is not a problem if it is just short-lived. Otherwise, code duplication is really, really bad. And let's just call it read. And let's say this is async. And an async function. What? Async because of this? What is that? Of error? Where does that come from? That's strange. So async read. Oh, giveaway time. So 1 nano goes to Sergio. Congratulations. So send 1 nano to Sergio. And unlocking the wallet. There you go. Congratulations. And restart the block timer. Okay. Back to the code. What is the error messages? Method read is not a member of TcpSocketFacade. Oh, because it's a trade. Okay. So this is implementing the TcpSocket extensions. So we have to say this is an async trade. And then we have to add the read function here. And yeah, so async trade is not, we have to import it. So now this looks better. So our async version of read it takes a buffer. And now I think we should but let's go one step after the other. But our goal is also to change this from argmutex vec-u8 to just a mutable u8 slice maybe. So buffer size, and this callback, we should be able to delete this callback, and instead it should return a result. For now, I'm just using anyhow. If you have a look at my code, I'm just using anyhow result everywhere, and that is because out of laziness, because I have not chosen a proper way of handling errors. And that's also on my to-do list, because I want to extract reusable libraries where you guys could just implement your own Nano projects with. And for that, I should find a proper way of returning errors. And that, yeah, if you have good suggestions, let me know. So for the time being, I'm just using anyhow result everywhere. So just an empty anyhow result. Trade requires 3 parameters. Yeah, so that I have to fix now down there in the implementation. So no callbacks. Instead, we return an anyhow result. And lifetime parameters are bounds or method read. Function and trade. Oh, okay. I also have to use async trade here. And yeah, so now it's complaining because I'm not returning a result. So can we refactor this now so that it returns a so maybe for the start I just return okay. Everything is gonna will be okay. Okay, so what does this do? It unwraps the buffer, blah blah blah, if not self is closed. So it still sets these timeouts. And what's this callback here? So I don't want to use I don't want to use callbacks. Read error, read successful. So these are observer calls. I don't know how to handle these right now. Maybe let's have a look down lower. Stream, what does this do? Socket state lock. Okay, so this gets our TCP stream that we want to use to read the bytes. So this code part should also be, we should also be able to delete this soon. And this gets the Tokyo runtime. And yeah, so this gets the Tokyo runtime and it spawns an async task. So that part is not needed anymore because our async function is executed in the Tokyo runtime already. So let's just delete all of that, or just the Tokyo runtime part. Like that. Hui, hey, Fiono. Nice background music today. Yeah, so I chose a different type today because, yeah, someone in stream said it's always the same playlist and he was right, or he or she was right, and I thought, let's try something else. So, something chill today. Jean Girelli, hey. Or Jean Girelli, hey. Post your Nano address if you want to take part in the giveaway. You still have 4 minutes left. Yeah, so, or maybe you are in the address book already. Let's have a look. Yes, you are. But it's a different address, so can we change that? No, we can just change the name. Edit entry. Can we delete the entry? Yeah, let's add a new one. So like here, I should write a Twitch bot or something so that you can register your addresses without me having to do it. Okay. Yeah, so this part, let's ignore this for now. And also, what is this? Okay, so if there is no... We can't just return, we have to return a result. So if there is no stream open, we should return an error. No TCP stream open. And this, so the Tokyo runtime, we should not need that. So let's delete these lines. So what does that do? So this is now the loop that reads from the stream. It waits until the stream is readable. What does it do then? It tries to read some bytes. And then it does the spawn blocking for the callback. But we don't have a callback and we don't need a spawn blocking. What we want to do is we want to return. Okay. And no callback. So what's going on here? If there was more, red was bigger than size, that should actually never happen. But okay. So again, there's no callback here. We just return error. The error is like read count is bigger than buffer size. It's bigger than buffer size. And so, okay, if there's any other errors here, we just return error. And what does this give us? It gives us, what is E? Error. Does this, can we convert that into an anyhow error? Can we say e.into maybe? Giveaway time again. So finally Bitcoin has another block. Just want to check. Oh, we can. Okay, let's spin the wheel. 1 nano for Hi, Spachista. Congratulations. Congratulations. There you go. So am I pronouncing your name right? I think not. Okay, so that conversion of the error worked. And restarting the block timer. So, and the last part here is if there's any other error. Is this also error? We can just the same thing, just return error. E.into. Oh. Like that. And then we have an else down there. So that function is just way too big. So if I have to scroll, to see everything of it, and if I had like just this else down here, there's just an else statement, and I can't even see the if statement because there's so much code in between. So that's function is way too big. I'm on the Robert Martin's side where functions should be very small. And the mega level says too many levels. That matches your username. The mega level. Yeah, too many levels. Way too many levels. Let's try to simplify this code. And if now says my rule is if it won't fit on the screen. Yeah. So, and if it won't fit on the screen, we can't do that. Just kidding. So what's that? Else, what is the if? The if is up here. If size is less than bufflen. Ah, okay, so if the buffer is not big enough, we need a bigger screen. Yeah. That's how we solve problems here. We need bigger screens, obviously. So that's like when back then the guideline was functions should never be bigger than one screen, but that guideline back then when it was popular, screens were just 25 lines long. 80 by 20, or what was it? 80 columns, 25 or 20 lines. So that is if the size is less than the bufflen, so that means the size, the read size was bigger than, oh, there's also a comment here, async read called with incorrect buff size. Yeah, so here we say, yeah, return it. So the buffer size, buffer is too small for read count. Okay. And this okay, can this okay be reached? I don't think so. Because here we have a loop, and in the loop we have returns. Can we delete this okay? No. Is there a way where we could reach this okay down here? Cryptic says, hey guys, am I too late? No, you're not late. You are not late. Post your Nano address if you want to participate in the giveaway. The next giveaway is in 6 minutes because we wait for another Bitcoin block. So what about... Okay, so that's still missing. So in the original code, we wrapped the callback in this callback, and what it was calling observers when there was read errors, and it called the observer when the read was successful, and it was yeah. So this setting the last completion, last receive time, but this is also when the read was successful. So we can just copy these lines into the place where the read was successful, and where is the place where the read... Here, this is the place where the read is successful. Self-clone? We don't need a self-clone. Can we just say self? Cannot find value len. Read successful. Len? So what is len? Len is size. Self. So maybe we can, maybe we can also later get rid of these two lines. The last completion time, the last receive time. Oh, Cryptic, you sent your address? Or are you in the address book already? I think you are. No, you are not. No, you are not. Let's add you. So here, that's you. And the spinner wheel. Okay. Okay, and how can we increase the read error count? Calling the read error observer. So let's find all places where we return error. So that is here. That is here. That is here. And here. I don't like to duplicate this error, read error observer. Read error. Maybe this is it's only interested in... In this line? What is that line? So this is an error when we wait for stream.readable. So this would fail. Yeah, so this is also something that could fail here. Okay, let's duplicate it first and then let's think about how we can remove the duplication. So we need to call the observer in here. Oh, where was it? Observer, read error. So down there. And also down there. Oh. Oh, it doesn't work? No. Let's copy it again. Read. Observer read error. Okay, so that's those two places. What? Is the Bitcoin block timer down to 1 minute again? Sometimes I don't notice how time flies. And this part, I think this is unreachable. I don't think the read count can ever be bigger than the size that we requested. That just doesn't make sense. This just doesn't make sense. I think I added this line because back then I wasn't sure. But how should it be possible that the read count would be bigger than the requested read size? I think this line can be deleted. Okay, 1 nano. 4. Hey! Hi, Jista. Congratulations again. So let's restart the block timer. Let's wait for another Bitcoin block. Let's wait for another 10 minutes. Bitcoiners, they must really love waiting. So this just increases the read count. Undefnal says, by the way, read and size, it can be the same, but no bigger. No? Yeah, so size. So the size must be the bigger of the two. So that size is the requested size that we want to read. And it can be that we only read the message partially. So that would mean that read count is less than size. And if that is the case, then we have to read again the remaining bytes. Wait a second. Where is the part? Oh, read OK. This returns error. This is not right. I think I made a mistake here. Let's have a look at the original code. This here should return OK. I think I made a mistake. Async read. Oh yeah, I made a mistake. I thought this meant it was okay. And this meant, yeah, I'm oh, guys, sorry. I made a mistake here. I got these two confused. So the successful read is in here, and the error part is up there. So this returns 0 as a read count. Yeah, that didn't look right. So now it makes sense. So like when we call read, try read, we get an okay, and n is the amount of bytes that were read in this call. So we add this to the total read count. And if our total read count is, so basically it can never be bigger than size, but I think I was extra careful here. So if the read count is bigger or equal to size, then we say the read was successful. And now we also have to say read error up there. So now it makes sense. So what I don't like is that we have the duplication of the observer read error here and here and here. And we don't have the observer call here, but really like this part, that should never happen. So if the buffer is too small for the read count, then we have a huge bug in our code. So this should just never happen. Like these errors up here, they can happen when we lose a network connection, for example. So that's okay. Read count was 0. Read error. What is this error here? So just whatever, a network error, can be any type of error. When we try to read from the stream. And then we have an OK down here. So okay, so that means this callback wrapper, we moved all of the relevant code down into the match statement, so that we can delete that. The self clone should not be used anymore. It's not used, so let's delete that. We're getting there, guys. We're getting there in small steps. Small steps. So I'm not happy with this function yet. It is still way too big. But in the future, so I'm planning a bit ahead here. So in the future, I want to move the responsibility of the timeout handling into the caller. So that means we can later delete these two lines. And I want to get rid of the socket state completely, so we can also get rid of these lines. And maybe also get rid of these lines. Yeah, and let's use an early return. Let's use an early return for this error case, because that would reduce nesting. So let's say if size is bigger than bufferlen, so just inverting the if condition, then we just return. Oh, so I like early returns because it reduces nesting. And I think that makes code simpler to read. So that means we can delete this. And we can delete this else down there. I still don't know how we can reach this OK line down there. Maybe we will find out soon. Okay, an early return for that case. And let's also use an early return for the cell. Ah, okay, we read. Okay, if it is closed, we can reach the OK if it is closed. So let's also use an early return. So if self is closed, and then let's not return OK, let's return error. Socket tried to read from a closed socket. Yeah, and then we don't need this if statement. And we don't need this OK, and we don't need that. Slowly we're getting there, very slowly. Small steps. So, stream, so this we will delete. This hopefully. We are going to delete this. Yeah, but the function got smaller already. So we are on the right way. Read. Okay, so I want to stop here. So we are not done yet. So this function is not done yet, but I want to use it because this new function, it is just a duplication of the async read to function, and let's find usages of that function, and let's see if we can use our new async function instead. So that is bootstrap client bulk push server, and in the socket the read impl. Yeah, and I think this is a very good place where we could use our new async function, because the read impl is the function that our message deserializer uses. So let's go back to the diagram. So I want to delete the TCP stream factory. I want to delete the TCP. No, sorry, I want to delete the Tokyo socket facade. So let's make it red. I want to delete it. And I want to use our testable TCP stream, our nullable TCP stream, from the message deserializer. And currently the message deserializer calls socket.readimpl. Oh, sorry. Spinner wheel time. So if there are new viewers and you want to participate, just post your Nano address in chat and you have a chance to win 1 Nano. Undev null, the game is rigged. One Nano. Congratulations. Yeah, so read impl. So our message deserializer, it calls read impl from socket, and socket then calls our TCP stuff. So that's why I want to make this one use the async version that we just wrote. And again, I want to duplicate the code, and then I want to make it async, and then when no one uses that anymore, I want to delete the old implementation. So the new one Where are we? Is this also a trade? No. Is this a trade? Yes, this is a trade. Okay. So then we have to add it to the trade. So async, no, this is the old, this is the copy. So async, read impl. I think we can also like delete this function. It doesn't make sense to have this function around. So let's call this read impl. Also the name is bad, read impl. Async, oh, async read impl. Also a bad name. So this one should not have a callback. It should be async. And it should return an anyhow result. Yeah, so let's add that one to this to the trade. Where is the trade? Socket extensions. Read impl and our async event read impl. Yeah. So what does this read impl do? So it gets the previous timeout. It sets the idle timeout. Then it calls async read, and after the read completes, we reset the timeout to the old value. Yeah, that was what I was complaining about earlier. This is just way too complicated. Why? So the way we should handle timeouts is maybe something like the join macros from Tokyo. So let's Google that. How is it done in Tokyo? The better way to do timeouts. There's just a timeout function. How is it used? Yeah, we can just say timeout. Can you see, chat? So we can just say timeout, and we give it duration. And then we can just give a function. An async function. So this is the way I want to do timeouts in RS Nano. Just way simpler. But I don't want to just do a huge redesign. I want to get there in very small and very safe and very simple steps. So let's keep it for now, and let's call our async, our new read function here. And this does not... Okay, so this does not have a callback. So, but this returns... This returns a result. And before we return the result, we have to reset the timeout to set default timeout value, previous timeout. So we have to call this here and delete the callback. So is this simpler now? So previous timeout, it changes the timeout to the idle timeout. The self-clone, we don't need the self-clone. Then it calls the async read, and then it just sets the previous timeout again. Okay, that looks good. So can we use our new implementation instead of the old one? And also let's add a to-do here. I want to add a to-do. Let's add a to-do, or maybe in the trade, let's add a to-do. Delete this. Okay, read impl. go back to read impl. Let's search for usages, and there are not many usages. We have only 2 usages. We have one in TCP channels and one in TCP server. So where can we? Let's have a look at TCP server. Ooh, what is that? All of the ugly code. So that's when you live stream live coding. You guys just see everything, all of the ugliness. But it's okay as long as we clean it up. Okay, so here is the message deserializer. So that was our goal from a couple of streams ago. So we want to use the async version for the message deserializer, and not a callback style like this one. So let's go into the message deserializer and let's see what we can do. So this is the read op. The read op, read query. Okay, guys, now you see it. Now you see it live. This is this horrible ugly type that I talked about in the last 2 or 3 streams. This is the callback type that is so ugly that I can't even spell it out. And this is the thing that we want to delete. The boxed-in fn arg mutex. So this is the type that I put into this diagram here on the bottom. Here it is. We want to get rid of it. So how can we do that? How can we get rid of this ugly thing? Do you have a good idea, chat? Do you have a good idea? How can we get rid of this type? So what comes to my mind is I could duplicate the message deserializer. Let's have a look at the usages. So here's the constructor, the new function, where we pass it in. And here's the usage. The read function uses it. And what is that? Received header. Yeah, okay, so I remember. So what the message deserializer does, it first reads the message type from the stream, from the network stream. And the message type is, I think, just 1 byte. And then it knows what type of message, or does it read the whole message header? Received header. Let's go back there. So this is where the deserializer starts. Yeah, header. Okay, it reads the full header, and the header has a fixed size. So we know how many bytes to read. So it reads the message header, and then in the message header there's a message type, and it then knows how many bytes to read for the full message. One Nano 4. Bob, congratulations. Yeah, so it reads the message header. It knows how big the message is after reading the message header, and then it receives the rest of the message. And that is why we have 2 calls for the read op. And yeah, I'm inclined to duplicate this. I could use if else and a flag, but that would just make the code even more messy. Chat, what do you think? Should we duplicate this struct and then find all usages of the old version and replace it with a new version and then delete the old version? Is this a good idea or not? Okay, I want to search for all usages of this read function. So channel in proc, TCP channels and server. Not that many, just 3 usages. So you know what, guys? If you don't veto, or what is it? Is that an English word? Veto. I'm going to duplicate it. I'm going to duplicate it, and then I'm going to delete the old implementation as soon as I can. So this is the message deserializer. So let's just copy. Oh, I can't do that yet because we have to pass in the read op, and the read op. So the read op is now not a boxed-in fn whatever, but it is an async function that returns the bytes. So we need a trade. We need a trade that we could use. We need an async trade. And how to call it? What is a good name? A trade that we could use. Oh, Amadeus said, oh, the timer isn't on. The timer isn't on. Sorry, guys. Yeah, Amadeus said the timer isn't on. Sorry, I forgot. All right, sorry, guys. But sometimes Bitcoin just takes longer than 10 minutes to create a block. So just to show how slow Bitcoin is. So we need a trade here for reading. So let's call the trade. Oh, chat, please help me. I have no idea what a good name would be. Oh, Colin is in the chat. Hey, Colin, how are you? Colin says, it's okay. It just adds some randomness, just like Bitcoin. Yeah, just what I said. I've made many Bitcoin transactions in the past. And I had to wait for, it happened to me a lot that I had to wait for an hour to get one confirmation. And it wasn't because I didn't pay enough fees. It was just like there was no block created for an hour. That happens. That happens a lot more than people think. That they have to wait for an hour, for a whole hour, just to get one confirmation. And then when you send the Bitcoin, let's say to an exchange, and they need 3 confirmations, it can be that you have to wait for 2 hours for your Bitcoin transaction to arrive. Happened to me. I had to wait for 2 hours for my Bitcoin transactions to arrive at an exchange. Before I encountered Nano. Yeah, I'm going to duplicate it. And I'm going to create a trade now for reading, and I call this trade read. Oh, I have no idea how to call it. So what should it? It should just read some bytes It should just read some bytes into a buffer. Buffer reader. I don't want to call it network reader because we really don't care where these bytes come from. So we just want to read a couple of bytes. Byte reader. Byte reader, bytes reader. Reader? But reader is maybe too generic. Buffer reader. Buffer reader. Buffer reader. That's a stupid name. I don't like it. Okay, I'm going to call it the stupid buffer reader name, and I hope that someone proposes a better name. And it will have an async function, read, and it takes this argmutex vacuate. And later we can, in the next steps, we can get rid of the arg and the mutex and the vec, and just pass in a byte slice, a mutable byte slice. And if not, a stupid buffer reader. Stupid buffer reader. Any more names? So it takes this arg mutex. So it takes the buffer, and then it takes the count, and then it takes nothing more. It just returns a result, an empty result. So let's import async trait. The import was missing. Buffer reader. Buffer reader. Buffer reader. Yeah. I've named classes with stupider names than buffer reader in my life. So I think that is a trait we need. So now that we have this trait, let's copy the message deserializer. And how can we call it? Okay, today is the day where I just pick stupid names. This is the new message deserializer, and the other one is the old. Or let's call this V2. So this name is temporary, by the way. So once we deleted this one, so let's add it to delete. So once we delete the old one, I can just rename message deserializer V2 into message deserializer. So the refactoring support in NeoVim is really good. So I can just hit the rename shortcut here, and then I can just pick a new name, and it would just go through all of my files and rename this thing. So I'm renaming it. So I name this one V2 for now, and later we are going to rename it back into message deserializer. So this doesn't have a read op, but it has a buffer reader, and the buffer reader is this trait here, buffer reader. So because it is a trait, we have to put it into a box. Oh, it's self. I forgot self. Like that. Okay. No complaints from the compiler. So let's now copy. Now I'm duplicating a lot of code, but it's okay. We are going to delete the old implementation as soon as we can. So let's just copy all of this implementation until up down there. So copy that. And let's paste it here. Import message initializer v2. And it takes... Nee Davis says, I don't understand any of this, but y'all keep doing God's work and making Nano awesome. Oh, thanks, man. So are you a dev yourself? So if I think this stream is just very confusing if you're not a dev, and also if you don't know Rust, because Rust is a confusing language. It is a hard language. So if you have never worked with Rust, then all of this async and whatever and traits and so on, and I think it's just very confusing. So this takes the buffer reader, and it is a boxed-in buffer reader. And we have to assign the field, buffer reader. And now we have, oh, now I see it. Now we have a read buffer, and we have a buffer reader. That's also confusing. Read buffer and buffer reader. Okay. So there should be compiler errors now, because the code that I copied should use the old. There are no errors. Oh, I did not copy all of the relevant code. I just copied the deserialize. So these single deserialize functions here, they deserialize the individual message types, and they use this stream trait that I wrote. And the stream trait is let's just open it. The stream trait, it just, I don't know if I want to keep this. I wrote it for moving the code from C++ to Rust, and it just has a read and a read bytes function and a read U8, and it just assumes that the buffer is filled with data already, so it is not async, and it just uses that. So that's the reason why we don't have any compiler errors here. We have to copy this one, the message deserializer ext implementation. Nee Davis says, the extent of my coding abilities is making tweaks to my old GeoCities webpage in HTML. But I like to try to absorb knowledge from people smarter than myself. Oh, don't consider me smarter than yourself. I just have experience with coding, that's all. But I found Nano a couple of years ago, and it fascinated me once I used it. Yeah, same for me. It really fascinated me once I used it. So time for another round of the spinner wheel. So now I restarted. Hey, Pace Bitches, this is now the wheel is rigged for you this time. Congratulations. 1 Nano instantly after waiting 10 minutes for a Bitcoin block. You get your Nano instantly. So, and if not says rigged. How do you get on the wheel? Yeah, just post your Nano address in chat. Just post your Nano address and I put you on the wheel. We still have, how many Nanos do we still have? 4 Nanos left. So 4 more giveaways. So this one I want to copy. Is that the right one? Yeah. I want to copy all of that for our V2 implementation. And I don't even think we need this arc anymore. So the reason why I have a trait here is because I had to implement it for arc because of the callbacks. The callbacks would require an arc. So arg is a shared pointer. So the callbacks would require an arg, but our new async code doesn't. Nidevi says, "Oh, you're using the UK quality. That's cool." Oh, and 2 more addresses. Okay, guys, let's add you to my address book. And so the name and the address. Oh, here. And Nano ETH, hey, welcome to chat. So let's add you your address too. Yeah. Nardo.eth, are you an Ethereum fan? I find Ethereum very fascinating, and I own some, actually. So... Okay, so yeah, I think we can later get rid of this arg stuff and just move these functions into our message deserializer without a trait in between. So so now we have our first errors that we have to fix. So read op, we don't have read op anymore. We have the buffer reader. Nardo.eth says, thanks for having me. Yes, I am an Ethereum fan and of ENS. Is that the name service? I don't know anything about it. Yeah, Ethereum is yeah, very fascinating. I'm really curious how it will turn out. Only for smart contracts, but for value transfer, Nano is best. Of course it is. Of course it is. And I'm so happy that Nano has no smart contracts. Yes, the naming service, yeah. So let's rewrite this part to use our async functions. So that means that means the read function has to be async. That means we can't use the message deserializer ext trait. Yeah, okay. So then we have to just inline. Sorry, but then we just have to move these 2 functions directly into our v2 message deserializer. We don't have to use a trait here. Let's just cut it here and let's just paste it here. And let's make it pop so that we can call them. And they don't need what is callback type? Yeah, we don't need that. Callback type. Error code. What is error code? Oh, okay, so this is from C++. This is just an integer value. So I don't want to use it. I would just want to use Rust errors, anyhow errors. And it returns an option boxed in message. Yeah, that's good. So I want to say read is async. And it does not get a callback, but it returns an anyhow result option in message. But why an option? Shouldn't it just return an anyhow result message? Also, box, that is wrong. A boxed message. Shouldn't it just return anyhow result boxed in message? I think that would be appropriate. Maybe we find a way to return that without an option here. Set status, set status. Set status, and then we have a self-clone. Okay, so instead of... So we don't need a self-clone. Oops. So instead of calling self.readout, we call self.buffer... Buffer reader? It doesn't find the buffer reader. Yeah. Dot read. And we give it... So what does the buffer reader read function take? It takes the buffer and a count. So what is the buffer? The buffer is... okay, we have to copy that arc clone. We have to clone the arc of the read buffer. The size, the read count is header size. And then we have to say await. And okay, so then we have to match the result. So if it is okay, what to do then? If it is error, what to do then? Oh no, we don't. We can just do an early return if it is an error, like that. We don't need a match. We can say let. No, we don't need to assign anything. We just say read, and if the read succeeds, then we can call self dot received header like that. Is that right? Header size? What is that line doing? If size not equal to header size? That doesn't make sense. If the size is not... So this, we don't have to copy that line because that can never happen. I think that's okay. We can just delete all of that. Okay. So, oh, and we have to remove that semicolon. Yeah, that looks good. Received header. So the received header does not need a callback. Let's delete the callback. But it should return. And anyhow, result option boxed in message. And it should be async. So, buffer, what does it do? It locks the buffer. It says stream adapter. So the stream adapter is the stream trait that I talked about. Nano giveaway, Nano giveaway, a new Bitcoin block. So 1 Nano goes to... Hey, your lucky day, Nee Davis. You join the chat and you win 1 Nano. That's cool. Congratulations. One Nano for you. There you go. And restarting. Yeah. So stream, where was I? Stream adapter. Yeah, so here, ooh. Here we have that, and then we call the message header from stream. Okay, so if we can't deserialize the message header, we have to return. Oh, we can just use an early return. So we don't need a match statement. So if we can't extract the message header from the bytes, we can just early return. Much nicer. So that code already is getting way better. If the network... So these things that you see here are just checks for the messages. So we have to make sure that the messages are for the right network, like beta network, test network, or live network, or dev network. So if the network is not right, what is that set status here? Oh, that's also something that I really don't like. I think we should return the status instead of having the status as a field. David says, woo, lucky day, baby. Yeah, and there are still 3 more nanos to give away. Set status, set status. So yeah, so that's also something that I want to change. Also, what if the message header can be... Was there no message, no set status call when the message header couldn't be deserialized? Let's go to the old implementation. No, there wasn't. That's strange. So maybe I made a mistake here when I ported it, or there is really no status update when the message header is incorrect. It doesn't matter. It doesn't matter because I want to get rid of the status field anyway. I want to return the status as a result when I read from the network. No status fields anymore in the future. So okay, let's keep the status for now. And so the network was wrong, so let's just say return error. Anyhow, can we just say bail? There's a bail macro that does the same thing. Bail invalid network. So if version using, so if the header network version is too low, we also want to say bail. Oh, we can return a parse status. Oh, that is better. Let's return a parse status. Then we don't... Yeah, I don't want to return an anyhow result. I want to return a result with either a message or a parse status. And then later I want to get rid of success and none and call it parse error. That's better, yeah. So I want to say this is just a result. Our status. Okay, so then buffer reader read. So if the buffer reader cannot read from the network, then I have to say map error. Okay, that's bad. So what is the parse status if there's a network error? What is the parse status then if there's a network error? Invalid, outdated, duplicate publishment. Okay. Okay, maybe I'm trying to get too many things at once. Yeah, so let's just say none from now. And later let's add a to-do here. Return correct error. Okay. Here's a weight missing. Okay. So what to do here? So header. So we read the message header from our stream. And what does this return? What result is this? Anyhow. So this returns an anyhow result. So when we can't deserialize the header, let's also say map error. Oh, and here we have to early return. So map error, and let's also say parse status none for now. So this is also something that I have to do. Return correct error. Why does it? That's just ugly. Let's just put it here. So let's do an early return here. So invalid network. So if the network is invalid, we say turn error our status invalid network. The same down there. We say our status outdated. Oops. Our status outdated version. And if the message type is invalid, we return we return invalid header. Is valid message type invalid header? There's an invalid header parse status, so let's use that one up here. Invalid header. Okay. Invalid header. Is there? Yeah. Okay. Is there no other? Is there no invalid message type? No. No. Okay. So many errors down there. So payload size. We get the payload size from the message header. If the payload size is too big, then we return message size too big. Okay. And if payload size is 0, then payload size will be 0 for bulk push and telemetry request message type. So then it will just call received message directly, and received message is not async. That's okay. Received message. What does received message return? Okay. We have to change this function also to return the message instead of using a callback. So this should return giveaway time. Finally a new Bitcoin block. Finally a new Bitcoin block. Gene Girelli. 1 nano for you. Oh. 1 nano for you. Ooh, successfully sent. How many nanos do we have left? 2. So this should return a result. Anyhow result, or parse status. No, it should return a result. Result. Yeah, I think we can get rid of the option here today. I don't think we need it. Parse status. Box. And also what I want to do in the future is I want to make message an enum instead of using a trait, because then we can get rid of the boxes. You might have meant to end the type parameters here. There's... Yeah. That was missing. No, result. Oh no. Here. Yeah, now it's correct. Okay, so we call self deserialize. And what does that return? It returns an option boxed in message. So it either returns a message or it doesn't. So when it returns a message, we say set status success. And then we call the callback. But in this case, we don't want to call the callback. We want to say, okay, some message. And what is the none case? So deserialize can return none. Does it mean it failed? Let's have a look at what deserialize does. When does deserialize return none? If the message type is invalid or not a type. But then it's an error, so... Okay. So that means it's an error. So that means we will return error. And what is the parse status? Okay, this is just in small steps, so I want to do this in small steps. So let's just return self.status, and later we want to remove the status field. Yeah, we fixed the errors. But there are more errors here. Oh, there are a couple of errors here. So the received header function still has many errors here. So we called received message. Yeah, so received message doesn't have a callback anymore. But it returns the message. And we have to return the message. So is that the last line? Is that the last expression in our function? Yeah. So let's remove the semicolon so that it returns the received message. I did not start the counter again. That's so strange. I checked it, I double checked it. I think there's a bug somehow, or no. Maybe I didn't. How late is it? Oh, just 20 minutes left. Yeah, don't worry, guys. Then we just do a very quick giveaway in the end. Okay, so we have to fix that part. We don't need a self-clone, we don't have a read op, but what we do is this. We do buffer reader dot read, and read takes the buffer and count. So this is the buffer. And the count is payload size. And what is that here? That's the callback. What does this return? Just an empty result. And what does this function return? Our status. So, so we have to say map error, and we have to say our status. Message type. We're also adding a to-do. Use return correct error type, error code. Okay. We do the buff read, so that means we can delete these lines, and then if there's error, it calls the callback. We don't have callback. If the size, what is that? If the size is not equal to payload size, so this also should not be possible. We don't need that case. It can't happen. But what we need is this here, received message. So let's move that line up here. Let's say received message. And received message doesn't need a callback. And what is size? Payload size. Almost there. We are almost there. So, received message. Yeah, we just have to adjust the received message so it does not call a callback, but it should return a result. Option box, then message. Or a parse status as an error. One, two, three, 1, 2, 3. Oh, that's too much. Okay, so now that is okay. Okay. Deserialize. Self.deserialize. It calls self.deserialize header and payload size. And it receives a message, and then in that case it is a success. So we return okay, some message, and we delete the callback. And if it is none, that means there was an error. So we return error, and we read the status field. And as I said, I want to delete the status field in the near future and simplify this code even more. So it's not simple right now. But, oh, Oh, there are errors. I thought we fixed it. So there is remove extra argument, so there's no callback anymore. Yeah, that's right. Where was it? If payload size is... Yeah, so if payload size is 0, we have to say received message. And received message returns the result. Is there a return missing? How does the message get returned? Received header? Callback type. It still has the callback type. That's wrong. The received header has to return a result. Option. Box, then message. Parse status as an error. Parse status. Yeah, so... Ooh, more errors to fix. Okay, so if the header is incorrect, we have to say return... Header, we have to say... Oh, we can simplify this. We can say header is message header from Steam, map error. Or does it return just an anyhow result? So parse, what is the parse status here? Invalid header. Yeah. Early return, and we can delete all of that. So if the network is incorrect, we have to say return error invalid network. Ah, didn't I? Didn't I? Oh, wrong struct. Undo. What? Oh, I'm working on the wrong struct here. Let's just undo all of that. It's late, guys. It's really late. This was the wrong struct. Sorry. But why did it show this as... Remove the extra argument. Did I work on the wrong struct? I did. Oh, I messed it up. Guys, I messed it up. Oh no. Let's use Git to fix it. I messed it up. The received message in the message deserializer. I have to work with message deserializer v2. Maybe I have the original code in the v2. No, this is the v2. I messed it up, chat. Yeah, it's late. It's late. So, 1 nano for Amadeus. Congratulations. One nano for you. So how late is it? Okay, so 10 minutes left. Can we fix this back in 10 minutes? I think we can. I think I'm going to just go to GitHub and copy the original code and replace it. So where is it? It is in Rust. Node. Transport. And what was the function name? It was received message. No. Yeah, received message has to take a callback. Received message. Here it is, callback. So this is the code. Oh. So this is the code I want, and this is, I made a mistake here. And where's this? Received header. This requires the callback. So we are, oh, no more errors. Can this be? Are we actually at a point where we can commit? Oh, I forgot to start the timer again, but it doesn't matter because I'm going to end the stream in a couple of minutes. And then I'm going to give away the last Nano. No more errors. Let's do a cargo check. Cannot divide amount by integer. Oh, that's something I did. What? I worked on this today. That has nothing to do with what we are working on. That's strange because I compiled it successfully before the stream started. Okay, so but that I think that means that we can create a commit. We created the v2 version of the message deserializer that is async. And then in the next stream, next Tuesday, we can replace the old message deserializer by our new implementation. Yeah, I think we made a bit of good progress today. Who uses the old message deserializer? Channel in proc, TCP channels, and TCP server. So next week, next stream, we are going to use our new message deserializer, our async message deserializer in TCP server and in TCP channels, and then in channel in proc. And then we can delete the old implementation. And I also want to spend some time simplifying the message deserializer a bit more, because we don't have to return options. And we have to improve the error codes. So there's still work to do, but I think this is okay for a commit. So let's reformat the code. And let's run the tests. Maybe let's run the Rust tests first because they are faster. And while the tests run, I can create the commit already. And says, I still think you should use the stupid reader buffer name. Okay. Let's see what the others think of that name. Yeah, I still don't like the reader buffer, the buffer reader name. So we add message to serial, add async version of message serializer. Yeah, add async version of message serializer. And okay, the tests pass, the Rust tests pass. So let's also build the core test. And let's run the core test. But let's run them in parallel. Okay, and while this builds, let's give away the last Nano. So let's spin the wheel one more time. And yeah, that was a productive stream today. We got an async version of the message serializer. And hey, Henny Davis, congratulations. 1 Nano, the last Nano is for you. So yeah, what we did today is we copied this struct, the message serializer, and the new one does not use the read query. It does not use this monster of a callback. It just uses async Tokyo and to read from the network. And next week, next Tuesday, we are going to continue with this refactor. And we are going to delete the read query. We are going to delete that. We are going to delete the old message serializer and use the async message serializer v2. So that's the plan. Yeah, chat. See you next Tuesday, and have a good night. Bye, everyone. And if not, the stream was fun as always. Nano is the light. Yeah, Nano is the light. See you in a week. Bye, guys. I had fun. See you in a week. Bye-bye.